Welcome to Differential Equations, section 4.3. This is activity 432. And so here we're given the differential equation y double prime plus 10y prime plus 34y equals sine of 2t. Okay, so first we'll find the general solution to the homogeneous equation. So our characteristic polynomial is r squared plus 10r plus 34 equals 0. And so then r equals negative b plus or minus square root of b squared minus 4ac. So then we'll just keep it like that. All over 2a. And then in my calculator, I saw that that's negative 10 plus or minus the square root of negative 36 over 2. So that's negative 5 plus or minus 6i over 2. So it's negative 5 plus or minus 3i. Okay. So that's our eigenvalue. So then our homogeneous equation, solution to the homogeneous equation is C1 e to the negative 5t times cosine 3t plus C2 e to the negative 5t times sine of 3t. Okay. Now, for part B, we're asked to find the complex solution. Okay, so here we have sine of 2t. So the exponential function that includes the sine of 2t would be e to the 2it, which is equal to cosine of 2t plus I sine of 2t, where this imaginary part, not including the I, corresponds to that sine of 2t. Well, okay, so then I think I'll name my complex solution xc, like the book was doing. So xc equals a times e to the 2it. So then xc prime equals 2i, a to the 2it, and then xc double prime equals negative 4, a to the 2, a times e to the 2it. And so then putting these into my differential equation, I have negative 4, then plus 10 times this one, so plus 20i, and then plus 34 times this one, plus 34 times a e to the 2it equals not sine of 2t, but the one that gives you it, so e to the 2it. Okay, so then let's see, we're asked to find a for that. So then a equals 1 divided by this together is 30 plus 20i. Okay, so then multiply top and bottom by 30 minus 20i, 30 minus 20i, so you get 30 minus 20i divided by, we'd have this term squared minus this term squared, but this term squared becomes negative, so minus negative is positive, so you end up doing 30 times 30 is 90, plus 20 times 20 is 30 times 30 is not 90, it's 900. So 900 plus 400 would be 1,300. Okay, that simplifies to be 3 minus 2i over 130. Okay, so we found A. So then part C, determine A and B such that yp is a particular solution to 432. Okay. So 3 minus 2i over 130 times e to 2it. Well, that's equal to 3 minus 2i over 130 times cosine 2t plus I sine of 2t. And so then we have to FOIL. So this is, here we go. The real parts would be, I'm going to leave the 130 out here. So you've got 3 cosine, and then minus 2i times I, so plus 2. So 3 cosine 2t plus 2 sine of 2t plus I times, my I will be negative 2 times cosine 2t, cosine 2t, and then also I times, so plus 3 sine of 2t. Okay, sorry, you can't see that. Okay, I'll go over it again. So I FOILed it, so I did a real term to real term, an imaginary term to imaginary term to get my real terms, and then my imaginary terms are imaginary to real, and then real to imaginary. And I have the I factored out. Okay, now up here, this is the imaginary part. So I'm looking for the imaginary part to this one. So xp equals imaginary part. So it equals 1 over 30, 130, times negative 2 cosine 2t plus 3 sine of 2t. Okay, well that's a lot of complex arithmetic. There's actually a way to do it even kind of a way that's a little bit easier and also shows a little bit more understanding of what's going on. So go back to the fact that I have, I solved for xc to be 3 minus 2i over 130 times e to the 2it. Okay. So that means that I can take this number, and complex numbers are not on a line; they're on a plane. So then here is 1, 2, 1, 2, 3. So this is each tick mark is like 1 over 130, and so then here. So this is this point right there. This point right here, blue is showing up a little bit. Maybe red will show up better. So this point right here is, that point is 3 over 130. And this point is negative 2i over 130. So we write our real numbers left to right, and our imaginary numbers up and down. And so when you add them together, you get this number in the plane right here, which is 3 minus 2I over 130. Okay? And so writing it in polar form means that you look at the distance from the origin and the angle from the origin. But we always do angle like that, going from the positive real axis counterclockwise. Okay? So this is just a little bit of trigonometry. So what is the length of the hypotenuse there? And how do you find that angle of the triangle? So the length of the hypotenuse is Pythagorean theorem, which you could also find by multiplying. You could find by, well, yeah, Pythagorean theorem. So the Pythagorean theorem tells us that the absolute value of this, that's not really the A, that's like the, no, that is the A, okay. So the absolute value A then is really, I'll factor the 1 over 30 out. 130 out. I get square root of 9 plus 4. So 13. Okay, so Pythagorean theorem tells me the square root of 3 squared plus 4 squared, or the square root of 3 squared plus 2 squared, so 13. Okay. Then, hold on, I'm going to pause real quick. Okay, I'm back, and we found the length of the hypotenuse of that number A. Then we want to know the angle of that number A. And so the angle of that number A would be arctan of y over x. So theta equals arctan of y over x. So in this case, we're talking arctan of, let's see, my calculator here, in radians, and then I'll take, so y is basically 2 negative divided by 3. Now, I would have got that same number if I had the 1 over 130 for both of them. And then we're going to take arctan. So I need to do, it's been a while since I looked at this calculator. Can I do a shift? Where's the shift button? There it is. Arctan of that. I get negative 0.58. Now, you need to be careful using arctan, because if I had the angle that was over here, I would have gotten the same y over x. So arctan gives you the angle that's only in these quadrants, and you got to use your noggin to know if you move it to this quadrant or this quadrant, okay? So theta equals basically like negative 0.588 and change. Okay. So then that means I can write A equals square root of 13 over 130 times e to the I theta, where theta is that. Okay. Then that means that A times e to, recall that my complex solution was A e to the 2it. So that means my complex solution is square root of 13 over 130 times e to the I theta, and then I'll multiply that. I'll write it in 2 steps. 2 times 2it. So then my complex solution is square root of 13 over 130 times e to the 2it plus theta I. Okay. So that means that, well, what this does is it helps us have a better view of what's going on with regard to how this thing is moving as a sine or cosine wave. So then this one for here, so recall that I have the imaginary solution because you go way back to the beginning. I had a sine of 2t on the right side, so that's the imaginary part. So then the imaginary part is this with the sine of that. So square root of 13 over 130 times sine of I times 2t plus theta. Because really I should have factored out the I here. That's how you change it into the cosine and sine there. Okay. So how does this differ from the other thing I have? Well, it's easier to know how to graph it and what it's doing. So instead of having, recall from the last section, where I did like the hard way, I had this number here, the 1 over 130. That didn't tell me that much. I got 2 cosines and 3 sines, negative 2 cosines and 3 sines. And that's actually also equal to this, where theta equals the negative 0.588. And so this tells me the amplitude of the wave. And this tells me how far off it is from starting at 0. Okay? And then I can also, for some reason, the book likes cosine better. So I'm going to do, you can change this to be xp equals square root of 13 over 130 times cosine of 2t plus theta minus pi over 2, where theta equals negative 0.588. So I'm just like, I'm too lazy to write the negative 0.588 there. But now I suppose I will bring out the handy dandy calculator. And where did I put it? And so then I've got my, let's just get the exact number. So the exact number was 2 negative divided by 3, and then the shift arctan, but in radians. Oh, for crying out loud. 2 negative divided by 3, and then equals that, arctan. Okay, so then I'm going to subtract pi over 2. And I get negative 2.15. So I can write my final solution as xp equals square root of 13 over 130 times cosine of 2t minus, minus 2.158799. Okay, so then this tells me the amplitude of the wave. This tells me the frequency of the wave. And this tells me how far off phase the waves are. And so this is kind of the solution that gives you the best understanding of what's going on. So that completes. Oh, now I want to plot it. So as long as I have that, I can plot it. Let me plot it in Desmo so you can see the intricacies here. So y equals square root of 13 over 130 times cosine of 2t. Let's make it 2x so that the graph's better. Plus arctan of negative 2 over 3 minus pi over 2. Okay, let's zoom in. Our y-axis should be around negative 0.1 to positive 0.1. There we go. And so then it's off phase in the amplitude. So if you graph like y equals square root of 13 over 130, that's the amplitude. That's how high it's going. And then it's a cosine, but it's been moved back because it's a negative number I have there. So it's been moved back, so it's off phase. And then it's going every x equals 2 pi. So every 2 pi, it's going through a cycle twice because of the 2 there. Okay, so that tells you a lot of it. So having it in this, writing it this way tells you a lot about what's actually going on. It gives you a better understanding of what the problem's doing. All right, that completes this activity.